interacting tank connected in series. Means we are going to discuss about chemical process control. Two interacting tank, two interacting tank connected in series. So we had to find out the transfer function of these two tanks which are connected in interacting form. Suppose these two tanks are as follows. The inlet flow rate of first tank is F0 and outlet flow rate is F1 from the first tank, and from the second tank is F2. The height in first tank is H1 and height of the water in the second tank is H2, and cross-sectional area of the first tank is A1 and cross-sectional area of the second tank is A2. If this one is tank 1 and this one is tank 2. Now we have to find out the transfer function of this system or this process. So what we can do, first of all, we have to apply mass balance on tank 1 and tank 2 to get the model equation and introduce the deviation form and take the Laplace transform. We will get the transfer function for the complete system. So let us take material balance on tank 1. So as we know that input minus output is equal to accumulation. Now for tank 1, input is F0 and output from the first tank is F1, and the accumulation will be dV upon dt, where V equal to A into H1, A1 into H1. For tank 1, where A1 is the cross-sectional area and H1 is the height of the water in the tank 1. So if we put here A1 H1 upon, it becomes A1 H1 upon dt, where A1 is constant throughout the height, so it will come out from the differential and it will give us F0 minus F1 equal to A1 dH1 upon dt. This is equation number 1. Similarly, we have to apply mass balance on tank 2, mass balance on tank 2 to get the model equation. So input for tank 2 is F1 and output for tank 2 is F2, and accumulation will be dV2 upon dt, where V2 equal to A2 into H2. So if we put the value of V2 over here, we will get A2H2 upon dt, where A2 is constant throughout the height. It will come out from the differential and we will get model equation for tank 2 F1 minus F2 equal to A dH2 upon dt. This is equation number 2. If the resistance over here is R1 and resistance from outlet of the tank 2 is R2, then F1 will be H1 upon H1 minus H2 upon R1, and F2 will be H2 upon R2. This one is equation number 3 and 4. Now, if we will put the value of F1 and F2 in equation 1 and 2, we will get F0 minus H1 minus H2 upon R1 equal to A1 dH1 upon dt. Similarly, from equation 2, H1 minus H2 upon R1 minus H2 upon R2 equal to A2 dH2 upon dt. On simplifying, we will get H1 upon R1 minus H2 will take common 1 plus 1 upon R2, R1 upon R2 equal to A2 dH2 upon dt. So this is equation number 5 and 6. So now from equation 5 and 6 we will get A1 R1 dH1 upon dt equal to H1 minus H2 minus H1 plus H2 plus F0 R1, and from equation 6 A2 R2 dH2 upon dt equal to we multiply by R2, so it becomes H1 minus H2 R2 upon R1 plus 1. So this is equation number 7 and 8. So now at steady state equation 7 and 8 gives 0 equal to minus H1s plus H2s plus F0s into R1, and 0 equal to R2 upon R1 H1s minus H2s R2 upon R1 plus 1. So this is equation number 9 and 10. Now equation 7 minus 9 and 8 minus 10. We will get A1 R1 dH1 minus 0 upon dt equal to minus H1 minus H1s plus H2 minus H2s plus F0 minus F0s into R1. Similarly, for second case, H2 minus 0 dt equal to minus a plus R2 upon R1 H1 minus H1s minus H2 minus H2s R2 upon R1 plus 1. On solving these two equations, we will get, on solving equation number let us assume this is equation number 11 and 12. So as we know that h1 minus h1s equal to h1 bar and h2 minus h2s equal to h2 bar. So equation 11 and 12 becomes a1 r1 dh1 bar upon dt equal to minus h1 bar plus h2 bar plus f0 bar into r1, and equation 8 becomes h2 bar upon dt r2 upon r1 h1 bar minus h2 bar r2 upon r1 plus 1. Now this is equation number 13 and 14. Now taking the Laplace transform, Laplace transform of equation 13 and 14, we get a1 r1 s equal to minus h1 bar s plus h2 bar s plus f0 bar s into r1. Similarly, for equation 14, a2 r2 s h2 bar s equal to r2 upon r1 h1 bar s minus h2 bar s ब्रैकेट में r2 upon r1 plus 1. So this is equation number 15 and 16. On solving equation 15 and 16, we get a1 r1 s plus 1 h1 bar s equal to h2 bar s plus f0 bar s into r1. Similarly, from equation 16, a2 r2 s plus r2 upon r1 plus 1 h2 bar s equal to r2 upon r1 h1 bar s. So this is equation number 17 and 18. Now on solving equation 17 and 18, we have to find out the h2 upon f0. So we have to replace h1 bar s from equation 18. So the value of h1 bar s will be h1 bar s from equation 17 will be h2 bar s plus f0 bar s r1 divided by a1 r1 s plus 1. So we have to put this h1 bar s in equation 18 to get the desired value, which is a2 r2 s plus 1 r2 upon r1 plus 1 h2 bar s equal to r2 upon r1 into h2 bar s plus f0 bar s into r1 divided by a1 r1 s plus 1. Now again we have to solve this one. a2 r2 s plus r2 upon r1 plus 1 into H2 bar S equal to, if you multiply it, R2 upon R1 into A1 R1 S plus 1 into H2 bar S plus F naught bar S into R2 divided by A1 R1 S plus 1. Simply I have multiplied A2 R1 into H2 bar S plus F naught bar S. We will get this formula. Now H2 bar S and H2 bar S take one side to get the desired results. So A2 R2 S plus R2 upon R1 plus 1 minus R2 upon R1 A1 R1 S plus 1. This will give us H2 bar S equal to F naught bar S into R2 divided by R1 A1 R1 S plus 1. So we have to find out H2 bar S divided by F naught bar S equal to, it will be R2 divided by A1 R1 S plus 1 whole divided by A2 R2 S plus R2 upon R1 plus 1 minus R2 upon R1 A1 R1 S plus 1. So this is the formula which on solving will get the results. Now on solving this, we will get H2 bar S upon F naught bar S equal to, if we solve it, we will get R2 upon A1 R1 S plus 1 and divide by, this will be A2 R2 S plus, on solving it we will get R2 R1 upon R1 minus R2 upon R1 A1 R1 S plus 1. So similarly, if we solve A1 R1 S plus 1 divided by taking LCM, this is A2 R2 S plus 1, this will give us R2 plus R1 into A1 R1 S plus 1 minus R2 divided by A1 R1 S plus 1 into R. We have taken the LCM of these two, R1 A1 R1 S plus 1, and on solving we will get this. Now on solving we get R2 upon A1 R1 S plus 1 divided by, on solving it we get A1 R1 into A2 R2 S square plus A1 R1 plus A2 R2 into A1 R2 S plus 1 divided by R1 A1 R1 S plus 1. So R1 to R1 cancel out, and this will be also cancel out. It will give us H2 upon F naught bar S equal to R2 upon A1 R1 into A2 R2 S square plus A1 R1 plus A2 R2 plus A1 R2 S plus 1, where A1 R1 equal to tau 1 and A2 R2 equal to tau 2. So H2 bar S divided by F net bar S will be R2 2 upon tau 1 into tau 2 s square plus tau 1 plus tau 2 into a1 r2 s plus 1. So this is the desired transfer function of two interacting time connected in series, where S2 bar S is the height in the second tank and F naught bar S is the inlet flow rate in the first tank. So this is the answer how we can find out the transfer function for the interacting time. So this is the procedure, step by step you can follow to find out the